Hi everyone, this is Jayashree, Assistant Professor, Department of IoT. So in this series, we discuss upon frequency response analysis. That is Unit 3 in control systems. So what is frequency response? So we are going to discuss about the response of the system for various frequencies values, how the system is, how the behavior of the system, whether it is in a stable state after attaining disturbance, when the system comes to stable state, different types of compensation devices. So those are the things we are going to discuss in this unit, in this topic. Right, right. So by the term frequency response, we mean the steady state response of a system to sinusoidal input. So in this, we are going to analyze the steady state response of the system to a sinusoidal input. There are various types of inputs you already know. Step input, impulse input, the ramp functions. So here, this is a ramp triangular sawtooth waveform. So here, in this frequency response, we are going to give a sinusoidal input to the system and going to analyze what is the output system will be. Right. So in frequency response method, we vary the frequency of the input signal over a certain range and study the resulting response. The output we call it as a response, input we call it as a signal. Right. Then the frequency domain transfer function T of j omega is a complex function of omega. It consists of a real part and imaginary part, right? So here it can be separated into magnitude function and phase function. So if you convert a rectangular form into polar form, so we get magnitude and phase angle. Now the magnitude and phase functions with real functions of omega, and they are called frequency response. So in this throughout the unit, we are going to find out all the values in polar form. So the response has some magnitude and phase values. We are going to plot in various types of plots. From those plots, we can determine what is phase margin and gain margin. Then how to improve phase margin and gain margin. That is also we are going to discuss. Right. Frequency response can be evaluated for open loop system and the closed loop system. So we can evaluate for both the open loop and closed loop system. The frequency domain transfer function of open loop and closed loop systems can be obtained. Domain transfer function of open loop and closed loop systems can be obtained from the S domain transfer function by replacing S by omega. So while calculating the response analysis, first step is we have to replace S by j omega. Then, so here I have given a transfer function of open loop. So G of S equals. So here we are substituting S equals j omega. So G of j omega equals. So here it is magnitude, that is modulus of G of j omega into phase angle of G of j omega. So this is my open loop transfer function. Next, coming to closed loop transfer function. So here there is a feedback signal H of S. So what is my closed loop transfer function? Again, I have substituted S equals j omega. So G of j omega into H of j omega equals G of j omega. It is modulus of G of j omega and H of j omega into phase angle of G of j omega into H of j omega. So this is a loop transfer function, and there is a feedback and all. We'll get a transfer function like this. Then closed loop transfer function. What is that? Closed loop transfer function. So m of j omega equals modulus of again m of j omega into angle of m of j omega. So here all the modulus functions, modulus of g of j omega, modulus of m of j omega, are magnitude functions, and the angle g of j omega, that is the angle represents phase functions. So here in throughout this unit we are going to separate magnitude and phase, and we are going to do and magnitude plot and phase plot. We are going to plot from those plots the frequency margin and gain margin, phase margins can be determined. Right. Thanks for watching. Thank you. We'll continue the topic in the next lecture. Thank you.